Hi guys, welcome to the fourth video of the integration series on Mathphile. In this video, we're going to learn about integrations in the form. So y is equal to integral of 1 over ax plus b dx. So we're going to learn about these integrations. Now, in the previous videos, we realized that we got integral of x raised to the power n dx. We get the final answer as x raised to the power n plus 1 over n plus 1 plus c, where we're told that n is not equal to negative 1. But the fact that n is not equal to negative 1 doesn't mean that when n equals to negative 1, this can't be solved. So a typical example would be, let's say y is equal to x raised to the power negative 1 dx. This can't be solved using the power rule because it's going to violate a lot of rules in mathematics. This will give us x raised to the power 0 over 0 plus c, and we know we can't divide by 0. So yeah, this for power rule is not going to work, but that doesn't mean it's not going to work when you've got an exponent of negative 1. So if you go y is equal to x raised to the power negative 1 dx, this can be written as 1 over x dx. So in the previous video, we were talking about the fact that you don't really need to know how to integrate. Once you can differentiate and spot some special functions, you are good to go. There was this question that we posed, that integral of 3x squared dx, which we didn't really need to solve this one. If you know the function to differentiate to get 3x squared, then we are good to go. So integration basically asks you which function are you to differentiate to get whatever is enclosed inside the integration. So in this case, we know that when you differentiate x cubed, you get 3x squared. So the answer to the question is x cubed plus c. So the same thing over here. Which function are you to differentiate to get 1 over x? So you can think through this. You can give yourself some time to think. Which function would you differentiate to get 1 over x? If your answer was ln x, natural log of x, then you are very correct, because d dx of ln x is 1 over x. So we can say that if we've got integral of 1 over x, this becomes ln x plus c. And we can use this concept to continue with today's lesson. So that's the main thing we have to take up from this lesson. So even though the exponent is negative 1, we can still work our way around it. And we're going to do an extended version of this, where the denominator is not just going to be x, but it's going to be a linear function. X itself is a linear function, but it's going to be in the form ax plus b. That is what I'm trying to put across. So we're going to try out integration of the form 1 over, let's say, 3x plus 2 dx. Now, I think in one of the videos I was advising we write everything in straight line. So in this case, y is going to be integral of 3x plus 2 raised to the power negative 1. In questions of this nature, where the exponent will be negative 1, I would advise you leave it the way it is and not to write it in a straight line. So you first need to identify that anytime you come across 1 over x as integration, you should be thinking about logarithm. Again, this integration is strictly restricted to additional mathematics. I would have said it in a different way if I was teaching A-level students. But because this is restricted to additional mathematics, you should look out for the pattern. The pattern is going to be 1 over a linear function or a constant function. It can be any number at all. This can be 4 over, or it can be 7 over. But for this question, it's just 1 over. Whenever you see that over an exponent, a linear function without an exponent, we should be thinking about the logarithmic functions. So in this case, you can say that the answer is going to be y is equal to ln 3x plus 2. Now, with the little catch, you multiply this one by 1 over the differential of what is at the denominator. So the differential of 3x plus 2 is going to be 3. Then we finish off nicely plus c. So we can say that y is equal to 1 over 3 ln of 3x plus 2 plus c. And that will answer the question. So you should look out for the patterns. Once you can spot this pattern, we know that that is going to be a logarithmic function. So assuming again the same question, let me copy this one to the next page. So assuming this question wasn't this way, but instead it was raised to the power 4, Then with this one, we would have written this one as integral of 3x plus 2 raised to the power negative 4 dx. Then we integrate from there, where we add 1 to the exponent. This becomes 3x plus 2 raised to the power negative 4 plus 1 is going to be a negative 3. Divide by the new exponent, negative 3, times 1 over the differential of what is inside, which is 1 over 3 plus c. But because this is not an exponent of 4 and it's an exponent of 1, we know that this is a logarithm function. So anytime we come across y is equal to integral of 1 over x dx, we should know that we're going to get something in relation to ln x plus c. So that is a pattern you need to identify as an hard math student. So let's talk more about other questions. Let's say y is equal to integral of 8 over 4 minus 5x dx. So you can pause the video and work this one out. So with this one, there are two ways to look at it. We can bring out the constants. I don't normally like doing that. You can bring it out by writing 8, then integral of 1 over 4 minus 5x dx. Then you integrate it from there, which is just going to be 8 out. And because the exponent has got no, the denominator has got no exponent, I know this is a ln function. So this can be written as ln of 4 minus 5x. Then when you finish up with this one, you multiply by 1 over the differential of what is at the bottom. So 1 over the differential of 4x minus 5 is negative 5. Then we finish off this nicely with a constant of integration plus c. So the final answer to this one will be y is equal to negative 8 over 5 ln 4 minus 5x, and that will answer the question. So that is how to integrate functions of this form. So just to recap wrap up, summarize all this, we get y is equal to integral of, let's say, 1 over ax plus b dx. The final answer is going to be ln ax plus b multiplied by 1 over the differential, so 1 over a plus c, and that will answer the question. And that will be all for today's lesson. We'll meet in the next one. Bye.